Okay, so now we want to talk about towing airplanes. Now, towing airplanes is something that you're going to do your entire career. You're either going to have airplanes pull up to the hangar and you're going to grab them and you're going to bring them into the hangar and play the whole hangar shuffle to make sure that everything's in its right place to try to maximize hangar space. That's one option. If you're on the line, you're going to be moving airplanes to gates, from gates, to maintenance, away from maintenance, all over the place. If you have to get one fueled, sometimes the fuel truck can't come to you and you move it to the fuel point. But not either case, no matter what the scenario is, you will be moving airplanes and you're going to learn how to do it here. Now, when you do it in class, it's going to be different than what you're about to see, because in class, you're going to have wing walkers, a tail walker, a person on the brakes, and a person that's actually driving the tug, and then the tug team commander or team lead. Now, these are the way the roles generally work. The tug guy, basically, his job is to just look forward and drive the tug, and then he listens to the tail and the tip and the wingtip wall walkers and the team lead for, like, guidance on speed up, slow down, so on and so forth. Now, the team lead, his job is coordination. He's listening to the wing walkers and the tail walker, and he's sitting right beside the tug driver, and his job is to basically try to synthesize all that information. It's generally your more experienced person, and there's generally certifications that you have to get to be the tow lead. And his job is basically to be ultimately responsible for how everything goes. If somebody says something, he's going to make sure that, like, that tug driver hits the brake, stops, or moderates his speed to either speed up because he's going too slow and we're never going to get there, or slow down because we're going too fast and we're walking everybody's legs off and it's operating at super duper fast pace. Now, the wing walkers, the wingtip guys, their job is solely that, the wingtip, period. Most of the time the damage happens, that's where it's going to be at. You generally don't run over something that's like way close to the tug because the tug driver sees it or whatever. Most of the time it's in a turn, and it's because somebody wasn't paying attention and we hit the side of the hangar or a taxiway ladder or whatever the thing is out there. But usually it's way out there. So those wing walkers are absolutely essential for safe movement of an airplane. Now, the tail guy, on the other hand, he's back there making sure that the tail doesn't swing, because there's some aircraft that, like, if you'll clear the wing, by the time that the turn's completed, the tail's out and it's even further than the wing is, and it could strike something. Or any number of cases where somebody approaches it from behind, is not paying attention, whatever. It's another insurance policy to have that guy in the very back making sure that nobody strikes the tail. Now, the tug driver, he's going to try to keep the pace at a brisk walk. That means that, you don't want to go too slow because you'll never get there, but you also don't want to go too fast for a couple of reasons. One, this is a lot of weight that you're moving. And so, when you're talking about moving like a 777 or 737, this is a huge amount of weight. I mean, the Lear itself is just over 11,000 pounds. 11,000 pounds moving at 20 miles an hour, you can go back to your basic physics class and think through what does it take to stop that. And it's going to be a lot of force. That you can't rely on the brakes on the tug to stop it, because the tug's brakes are meant to stop the tug, not the tug and everything else. And that's why you have a guy that's sitting in the cockpit that's monitoring the aircraft brakes. Make sure before you take off, the aircraft brakes are charged and they're good to go. And if anything happens, they should all be on headset, and everything should be done over radio communications. And the aircraft brake rider is looking at the team lead down at the tug. If he tells him to cut off, brake, or whatever, he'll lock those brakes up and stop the airplane from moving. Not the tug, just the airplane. Because if you rely solely on the tug, the airplane will overpower the tug brakes and push it through. And there's been a lot of people that got hurt because of that very thing, that the brake rider wasn't paying attention, or something happened too fast for them to react. Now, that being said, this is one of the more dangerous things that you're going to do as an aircraft mechanic, because you're out on a flight line. You can hear that there's a plane cranking right now. There's always stuff that's happening, all right? So that dynamic environment adds to a lot of just chaos that could potentially happen. And if you're not on your game, somebody could hit something, somebody could hit someone, or whatever. I was working in Renton at the 737 MAX factory when a guy at 2 a.m. was walking the wing of a 767 and decided to take out his phone. It's like 2 a.m. They're not really paying attention. He tripped and fell, and then when he fell in front of the landing gear, and the plane ran him over and killed him. This stuff happens all the time. And so take this seriously, because if you don't, you could get yourself hurt, you could get a plane damaged, you get somebody else hurt, and we don't want that. Now, what's about to happen is we're going to tow the Aztec down to the wash point, and we're going to hose it off. And we're going to go over what an aircraft wash looks like. You generally will, depending on where you're at, and it's all kind of like local policy of how they want aircraft washed, but generally speaking, you're going to do mostly water. Sometimes there may be a foam or some sort of like soap that gets used, but those run into a bunch of complications because, for one, you don't want to use solvents that are really, really aggressive, because it could lead to corrosion. Number two is the runoff, like that, all of that chemical has to go somewhere, and you don't want it to go into like your local creek and stream and ocean and so on and so forth. And so we have to have a way to catch it. If you don't have a wash pad that's set up to do exactly that and do it correctly per EPA guidelines, you can incur fines for the company, for yourself, maybe even jail time, who knows. And in the worst case scenario, it's going to jack up the fishing for everybody, because off the chemical goes, and that's going to mess everything up. So washing is something that you will do, but it's going to look different everywhere you go, based on the airplane, based on the location, based on how dirty it is. Today, we're not going to be using any soap. We're only going to use a water hose to basically just get the dust and dirt and grime off of the Aztec. Okay, so let's talk about a couple of things that we're about to need. One, we need the aircraft. You can see the Aztec is ready to go. So we're not really going to talk about the aircraft just yet. We're going to talk about how we get it set up, make sure that it's good here in a minute. But right now, we just have an aircraft. The next key ingredient we need is a tug. So as you can see, our tractor is our school tug. There's a couple of other types of tugs that you need to be aware of. One is called a pushback, which is essentially just a massive machine that's used to move heavy commercial airplanes back and forward from the gate. You can tow with them as well. There is a legit aircraft tug that you'll see that they're flat, so that way the nose gear of an airplane can run up on top of them, and they'll ratchet strap them in and they tug them around that way. That's your ideal scenario for a heavy commercial airplane. Obviously, we don't have things that are that big here, and we also don't have that much money because they're very expensive. The other one that you'll see used a lot in general aviation, corporate aviation, and even in heavy commercial aviation, or variants of it, it's called an Electra. What an Electra does is it's electric. It is a ramp that will pull up to an aircraft. You'll roll the nose gear up onto a little tray. That tray will jack the nose gear up, and you'll have either a chain or a ratchet strap or whatever the variety of your securing device is. It'll secure it, so that way the tug becomes the steering agent, not the nose gear anymore, and the aircraft can pivot right there. But effectively, it makes it all one piece. It makes it towing very, very easy and very, very nice. And you'll see guys use those. Those are probably more common at your FBOs and stuff like that, because they are like really, it's worth the investment. For us, we use a 40-horse tractor, a little Bobcat, and that's because we need to be able to do multiple things with it. Like towing aircraft is only like a part of the thing. It's also our forklift for unloading trucks, engine changes, moving things around the hangar, that kind of thing. It's a lot more better suited to our needs than Electra was. So instead of having two pieces of equipment, we have one. That makes a lot more sense for us. Now, the other kind of key piece of the towing operation is the tow bar. Now, here is a tow bar for a Piper Cherokee. It's one off of my plane. You simply slide it into the nose gear and it secures it, and then you can tow it by hand. It's not meant to be used with a tug. That is probably going to be your most common form of moving aircraft around. What you don't want to do is grab the prop and pull on the prop, because it puts extra wear and tear on the engine and the seals that are being affected by you yanking on it that way. So try to stay away from that. Sometimes that's just like the easiest, best way to do it, but as a general principle, use tow bar. There are all sorts of tow bars that are out there. The one that we currently have hooked up to the Aztec right now is a universal tow bar. Now, what makes it universal? Well, one, it's scissors. It can extend or contract based on the width of the nose gear. And you'll find that different aircraft manufacturers have different size tires, size nose gears, all the good stuff. And so you want to be able to try to, if you're going to buy one thing that kind of fits everything, it needs to be able to be customized like that and be able to widen or close. The other thing that makes it universal is that there's two types of lugs on there. You'll see big lugs that go in your heavier jets. On the nose gear that you'll see on the axle, there's like an open port, for lack of better terms. It's an open hole. And then the lug fits right in there super duper tight. And then you can take on the universal, you can tighten it up and make sure that it's super secure. In other applications like the old tow bar, like this, you undo that friction screw right there, it's that screw, and it will change for you. It comes out and slides in, so that way you can adjust the width. It only has one type of lug, so you notice that it has to take that size for it to secure the aircraft. So you'll always want to tow an aircraft with the right tow bar with the right lug, because any sort of play can open up yourself to the possibility that lug comes out and the aircraft departs the tug, and that is a bad scenario, especially if you don't have brake riders that can stop the airplane. It's just going to careen off, and an airplane is extremely expensive to have just doing its own thing, going down the fly line into other airplanes or into even a live runway or taxiway, which would be really bad. So make sure you use the right tow bar secured correctly to whatever tug or in your hands, so that way you can keep positive control of the aircraft no matter what. Okay, so let's talk about setting the airplane up to be towed. First off, you notice that the prop is straight up and down. We don't want that. The reason being is that like the taxiway and the apron that we're gonna be towing across isn't even. It's not a flat, even surface. So those little hills and bumps could cause a prop strike. And prop strikes are really, really bad. It's gonna be a lot of rework both to the prop and the engine that it's attached to. So we want to prevent that. So what we want to do is turn that prop level. So now that it's level, we don't have to worry about that. The other two things that we really want to be, the other three things that we really want to be concerned about, so one is make sure that the doors are secured. Aircraft doors are meant to take pressure from the outside, pushing up against aircraft doors are meant to take pressure from the outside, pushing up against the fuselage. And sometimes in some scenarios, they lock in place so that way they can be pressurized from the inside. But what they are not meant to take pressure from is from the wind gusting backwards down the fuselage and pulling on that door or that window. When that happens, you'll overextend the hinges and you'll have a broke door, and likely probably more. And then the thing with airplanes is they don't break very well. Like whereas like I can take my Tacoma and drop a ton of bricks on it, and it's going to drive away and it'll be okay. It might be ugly, but it'll be okay. But like with an airplane, you drop a ton of bricks on it, it is totally useless, and it breaks in the most fantastic fashion, in the most expensive fashion. So you don't want to do that. So you want to be real careful and real mindful of around them at all times. They're very, very fragile because they're lightweight and they're made to fly. They're not made with durability in mind. So make sure the doors are closed. The other thing that we want to check and make sure of is that the brakes work. That not only do they work, but they also do they have enough fluid in them for the brake rider to step on and actually effectively stop the aircraft if needed. That would mean that they're connected, for one. They have the pads are good. Most of this stuff is pretty standard, and you'll have that just by virtue of having a working aircraft. The one thing that you do want to check, especially if it's an aircraft that's sat for a long period of time or something that you've just received from a customer, is making sure that there's enough fluid. Most aircraft hydraulic fluid and brake fluid is 5606. It's pretty standard, and it's easy to top it off and make sure it's there. If not, you could end up having, you'll be standing on the brakes and nothing will be happening, and you'll just be a part of a crash and be wondering what's going on. So there's that. Before you take off towing it, disconnect the battery. Reason being is that, like, for one, the brake rider may like hit a switch for a light or something that creates a parasitic drag on the battery itself, and so you definitely want to try to mitigate that the best that you can. The other thing is that, like, if we're going to be moving it into a state of maintenance, then we're going to most likely be messing with things that are either electrical, or in this case, we're going to be spraying the Aztec off, trying to get some of the dirt off before we have a big meeting at the hangar. And when we do that, you generally don't want to have any electrical current going through the aircraft, because electricity and water don't necessarily mix very well. All right, so another thing that you want to make sure of is make sure that the tires are ready to be towed. As you can see, the Aztec's tires don't hold air very well, and this tire is super duper low. The last thing that we want to have happen is to have a blowout as we're going down the taxiway, because it's a very inconvenient place to have a problem. That means that we would have to, like, stop what we're doing, plug up the whole area while we replace the tire, and then, you know, tow it off to wherever it's going to be. Also, you're going to damage the rim. You're going to damage no telling what else. So make sure the tires are properly inflated before you tow it somewhere. Okay, so behind me is the yellow taxiway line. That line is always the dead center of any taxiway that you're on, whether or not you're towing or driving or taxiing an aircraft. Always have the taxiway line go in between your legs. If it's going in between your legs, it means that you are generally centered on the taxiway, and then the wings will always be clear of any obstruction, because if you notice, there's nothing on the taxiway. It's just asphalt. So if you're centered up on that like that, then we know that we should be good to go. Okay, so now that we're actually on the aircraft, everything's hooked up and we're ready to go, what are some of the rules of the road that we need to keep in mind as we tow the airplane? Number one, operate at a brisk walk. You don't want to be going too fast. You don't want to be going too slow either, but you want to make sure that you don't exceed a brisk walk. Number two, never, ever, ever fixate in one direction. You're always scanning. Keep your head on a swivel and make sure that you watch everything that's going on around you. You're watching for other aircraft. You're watching for vehicles that are coming and going, especially if you're in a busy airport. You're going to have all kinds of tricycles and golf carts and gators and all kinds of things coming and going. And so you want to make sure that you protect your airplane and you don't run anybody over. Number two, always, always, always glance over at the wingtips. If you can at all see, unless you're part of a big tow team, always be watching the wingtips and make sure that nothing's going to get away. When accidents happen is whenever that's not happening. Generally speaking, people don't want to run into things, and so, like, if they're just simply like taking note of their environment, they don't run into things. But your kind of other rules of the road is, like, we'll show the non-movement line here in a minute. You don't want to exceed past that non-movement line, because if we do that, we have to call the tower, because that's in their controlled airspace. Inside of the non-movement line, we can come and go as we please. So as long as we are badged, and our policy is as long as we have a high vis vest on, so that way we can keep everybody safe. Live airplanes that are moving around and stuff, we don't want to get in their way. We always defer to them. If we can get out of their way and let them come by, we, generally speaking, have a better timeline and have more control of the situation than an airplane that's actually just taxiing by itself. So always defer, give them give them the road, so that way they can be on their merry way. Okay, so we've towed the aircraft down to the T-hangars. Now we're going to give it a bath. We're going to wash it off. Today we're not going to be using any solvents, but I'm going to insert a video probably right here. Okay, so here's your quick down and dirty class on solvents. All right, so there are a few different kinds of solvents. One are detergents and soaps, which you're going to use pretty regularly, actually. There's all different types out there. You'll see all different types of vendors. If you go to any shows, they're always trying to sell you the next greatest and latest thing for washing airplanes. They all generally work. Some are better than others. You know, it's like certain body parts. Everybody has one. And they all stink. You know, like so that kind of thing. So you'll see old guys that are just like swear by this certain type of solvent or thing to clean the inside of the airplane with, or something like that. Don't get hung up on any of them. They generally all kind of work. Find one that you like and stick with it. The other one are alkaline cleaners. I'm just going to read this out of the 8083. It says most of these agents are water soluble and thus have no fire hazard properties. So alkaline cleaners that they can dissolve into water, and because of that they're water based, so that they won't catch on fire. They have an inherent caustic character to increase their efficiency, so they'll cut grease really, really well. But result in somewhat greater deteriorating effects on certain fabrics and plastics. So basically, don't get this stuff on the interior of the plane, which you shouldn't anyways. And also, there are strips that you'll find in between like wing-to-body joins that you get certain types of cleaners on them. They'll eat them up and you'll end up replacing them anyways. All right, so another type, acid solutions. Okay, a number of proprietary acid solutions are available to use as cleaning agents. They are normally mild solutions designed primarily to remove carbon, smut, and corrosive stains. I'll tell you, I've done this for quite some time now, and I've never used an acid solution, at least not one that I knew was an acid solution whenever I was using it. That just generally sounds bad. Generally speaking, whenever you're washing aircraft, it's a pretty mild experience. This isn't like generally speaking, you're not getting it all super sudsy and soapy and stuff like that. Now, I have done that before, especially if it's going into like some sort of heavy maintenance. We did it in the Army all the time because we flew in the desert environment in the middle of the two wars, and any sort of hydraulic leak, fuel leak, oil leak, anything like that, on that Cark paint that those Army helicopters are painted on, they basically turn into a magnet for dirt. And so the only way to really get it out of the Cark is to use something to really cut it off with. So we had a type of detergent that would spray on there, it would foam up, and it would draw out all of that stuff, and then we'd come back with high pressure water and then knock it off, and it worked pretty well. But mostly on the civilian side, you generally won't see a lot of this type of stuff. Like, you'll see some places that will wash aircraft, and you'll see some guys that even specialize in that. That's kind of like their business, is they come out and they wash your aircraft and detail the inside of it. I would almost always defer to those guys and let somebody else do like the kind of high level washing. You as an A&P, for the most part, on these detergents and stuff, you're going to be kind of like limited. You want to clean to inspect, because like you can't inspect something that's fundamentally dirty, so you need to be able to at least knock all the dirt off, and so that way you can see it. But when it comes to like a lot of these like specialty chemicals and stuff, and that are really, really detailed, let the other guy do it. Deodorizing or disinfecting agents is category number 4. It's a number of proprietary agents useful for aircraft cabin deodorizing or disinfecting or non-flammable. Once again, it's kind of like interiors is its own kind of subset inside of aviation. If you want to be an interiors mechanic, maybe that's something that you're into, and there's people that are. I've met them before. They're great folks. Then you'll start to kind of dig into like some of the specifics of like, you can use this on polyester, you can't use this on cotton, and so on and so forth. But every single one of those fabrics and materials have certain limitations of what you can actually use on them, and you'll need to take it by case and make sure that you know what you're working on, and make sure you're looking at the detergent or whatever the chemical is that you're using, and it says do not use on, pick a thing, so don't combine those two. Another one are abrasives. Some are proprietary, non-flammable, mild abrasive materials available for rejuvenating painted and polished surfaces. They present no fire hazard. So like you'll see certain types of material that has like grit in it, kind of like that those orange pumice stove that you use to clean your hands in the shop. That'll be kind of what they're talking about there. But these are even finer, and they're made to like bring the life back to paint, or specifically in polish. You start to see chrome aircraft, you'll start to see that kind of material being used there. Generally speaking, not something that you'll deal with on a day-to-day basis. And then lastly, dry cleaning agents. These are petrochloroethylene and trichloroethylene, and used at ambient temperatures, are examples of non-inflammatory dry cleaning agents. They have a toxicity hazard requiring care in their use. Not something that I've ever seen, but something that you could see, so know that it's a category that's out there. So there are a lot of flammable agents, and you will see those specifically for cleaning power plants. It seems to be the most common thing that they get used on. It could be anything from avgas. I've seen people use avgas to something that's very, very specific. but to cut through the grease and the oil, and that's where you really need to clean a lot of whenever a plane comes into annual and you're trying to like inspect. You can't inspect what you can't see. So if there's a bunch of like oil and junk and grime caked up onto it, you can take a shop towel and kind of go over it, but you might have to do a little bit more to actually get there to where you can see it. And all of those that you're going to use in like solvent tanks and stuff like that, they're all super flammable, and they're not good for you. So try to keep them off your skin the best you can, degrease away and contain it so that way it doesn't go into the runoff anywhere, because that's also not good. Anyways, back to aircraft wash. Okay, so that's solvents. Today we're not going to be using any of that. We're just going to be using water because we just need to get the dirt off the Aztec. It's pretty nasty, actually. So a couple of rules of the road for doing any sort of high water or high pressure application of any sort of chemical whatsoever. You don't want to spray anything to do with the pitot-static system directly. You don't want to spray the pitot tube directly at it, and you don't want to spray the static ports directly at it. We're going to take blue tape. We're going to cover both of those up as a kind of an extra measure to keep the water out, because we don't want water in that system at all if we can help it. Whenever we use the blue tape, we want to put the non-adhesive sides aside towards the opening. So that means that we're going to take a piece of blue tape, we're going to fold it over and make it like a little just a little piece of paper basically, and then we're going to tape that over the top of the static port, so that way none of the adhesive has any chance of getting into the static port itself. And we're going to do the same thing for the pitot tube. We're also going to secure all windows, cowlings, and doors. I'm actually going to go a step further and take the air vent that's on the Aztec, and we're going to tape it up because I don't trust it to not fly open. You don't want to spray water directly into anything where there's avionics, anything where there's where people are going to be, because water's not meant to be there, and it's very bad for it. Okay, so got our blue tape. We're going to just rip off a piece of it. You got the sticky side right here. We're going to just double it over to where you have just basically effectively like a piece of paper. Put that over the nose of the pitot tube, and we're going to tape it on. All right, and then the pitot tube is ready for wash. Okay, so the static port on the Aztec is actually integrated into the pitot tube. So we just tape this one up. The static port right here is a series of little holes that go underneath. Now, most static ports aren't that way. They're actually a disc that's on the side of the aircraft. So we'll show one on the Lear so you can see it. This is the same principle. We're going to tear off a piece of tape and double it over, just like so. We're going to close that up, and then we're just going to tape it on. Now afterwards, whenever we take this off, we're going to want to take some isopropyl alcohol and rub it over there and make sure that we can get all the adhesive off, because if we turn the pitot heat on, it's going to burn and it just creates a mess, and you don't want that. Okay, so once you're done towing an aircraft, you need to put it somewhere. There's two different kind of possibilities of where it could go. It could go in a hangar or on a flight line. So we're actually going to talk about the hangar bit first, and we're going to use the Lear as kind of our trainer, and then we'll talk about what does that look like, how is it different whenever it's on a flight line, it's out by itself. So first off, inside of a hangar, fire is probably one of your biggest concerns. You want to disconnect the battery, you want to disconnect ground power, make sure that it's not plugged up and left plugged up for a long period of time where it could get hot and spontaneously combust. If the maintenance manual or the local policy dictates any circuit breakers be pulled and lottoed out, you want to pull them, put a skylock on them, and tag them as appropriate. You then want to make sure that it's chalked. Now, like you'd say, well, why would you want to chalk an aircraft inside of a hangar? Well, what if there's an earthquake or some sort of weather event, or somebody just leans up against it or whatever? You want to have a low-cost method to stop it from rolling, which is a chalk. We have them. Why not use them? You want to make sure that it's grounded, so there'll be a static grounding port, and you'll plug it up, and then you'll ground it off into the hangar. They haven't installed ours yet, so we won't be doing that today, but I'll show you where the static port is, or the static electricity grounding point is on the Lear. You'll want to also, and it's something that's unique to a lot of jets, is put a tail stand on it. Now, you won't generally see this on like single engine airplanes because there's so much weight up front, even though they can still tip over backwards, but you'd have to open up and access the fuselage and go all the way down to get to that tipping point where it's going to fall backwards. On a jet, however, you will typically have people that are seated past the CG. The question becomes, like, how far back do they have to go before they tip backwards? Well, we're just going to take that out of the equation, and we're going to show you what it's like to put a tail stand on the Lear, so that way, even if someone were to go all the way to the back end and cause that plane to start to tip, it has that stand that keeps it from falling. Other than that, drip pans as needed wherever they need to go, and close the door and secure the aircraft is really how you secure inside of a hangar. You also want to make sure that any pitot covers or any sort of what they call flyaway gear, means that the gear that you take off before you fly away, usually it's marked in red and it will have like remove before flight on it. You want to make sure that that's on there. And all it is an extra layer of protection to make sure things that specifically FOD doesn't get into the airplane. A lot of times engine inlet covers will have them, pitot tubes always have them, and that kind of thing. So like make sure you have that on there. Another attribute of pressurized aircraft that's somewhat unique, you could have it in non-pressurized aircraft, but it's fairly rare. And the systems are more self-contained, so that way they're kind of self-securing in a lot of ways. Like you wouldn't turn your oxygen on unless you were using it, and most likely you're going to turn it off to put it away. But on pressurized jets, where you're not having supplemental oxygen on your face and you're not thinking about it, it's very easy to forget the oxygen. And so we're going to show you how to secure the jet in terms of turning the oxygen on and off. Now, you generally don't want to leave oxygen on because it will slowly deplete. Every system has its leaks, and oxygen will find its way out, and it'll go down. And you end up having to pay for that to get it to be reserviced. And so generally speaking, you want to turn it off at the tank, so that way you don't have to worry about that. The other thing with oxygen is that it's highly reactive to petrochemicals. So if, like you say, you leave it on and it's going somewhere in the jet, somebody walks in with like grease and stuff on their hands, it can explode and cause fire. It can also blow up if you were to leave it on and it gets into a container and then there's some sort of a spark. So it's just generally speaking good to just have the oxygen turned off, so that way you don't have to worry about any of those things. And it's part of the kind of the standard procedures for securing a jet inside of a hangar. The green indicates that it's an O2 up. All right, so you see our O2 bottle down here. This is how it pipes into the rest of the aircraft. We're just gonna come up here. It's currently turned off right now, but we would just twist this cap back until it clearly says on or off, and then we know that the O2 is out. Now, securing outside of the hangar, a lot of that stuff still same applies. You generally won't have drip pans because they'll blow away. You generally won't have static lines. Even though you could have either one of those depending on the situation, but for the most part, those two don't exist whenever you're taking a GA airplane and you're just tying it down. If you were like a fly-aboard mechanic with a jet, most of the time they just lock it up and that's it. You'll chalk the wheels and leave it. If you needed to tie an aircraft down, we're going to show you a hurricane hitch, and then we'll show you a bowline knot. Now the bowline knot is actually in the 8083, AC 4313, all that good stuff, and it's a good knot. There's nothing necessarily wrong with it. The hurricane hitch though is a little bit better because as the plane starts to list with the wind, it'll actually tighten itself down. It's just a modified trucker's hitch. There's nothing really that super special about it, but it's good to know. Okay, so here's our rear tie down for the Aztec, and we're going to first do the bowline knot. Now the bowline knot is an old Boy Scout classic. It's really easy. It's useful for many things, not just tying down airplanes. And then this would be the same if you tied it down on the wings or anything. It's just easier to show you on the tail. Well, first thing that we're going to do is we're going to thread our rope through the tie down, and then we're going to come down here. We're going to make a hole, make a little loop. All right. There's an old Boy Scout story about a rabbit in a tree. Now, if you imagine, so let's just take that out right fast. Imagine this is a tree, okay? And then the loop that you made is the hole, all right? The next character in the story is going to be a rabbit. The rabbit is the other end. He's going to come out of the hole. He's going to look around and think, like, I'm going to run around this tree and see what's up. They're going to run around the tree. Now, this is where the story gets a little weird. If you try to make him run around the tree and you just go straight back down to the hole, that won't work. You've actually got to go, when you go back through the hole, he runs around the tree and goes through the hole. He's actually coming up through the hole again a second time. That'll wrap around the backside. You then just simply tighten the knot up, and boom, you have a bowline knot. Super easy to tie. It can hold a lot. It can also cause a lot of mistakes if you don't tie it right, because it'll look right, but then it will slide and then eventually give way, and it won't hold your aircraft down. Now, the superior way, in my opinion, is a way bush pilots up in Alaska tie their aircraft down. Now, for this, you need to tie a loop. Let's see if we can get us a good loop going. Might have to change ropes if it's not long enough. Okay, so we have our loop. And all we did was it's a double overhand with a loop. You just simply double the knot over, make a figure eight, and off you go. All right, so we have a loop. We're gonna go through said loop, and we make what is the beginning of a trucker's hitch. We'll then take this, the loose end, like so, and we're gonna thread it through and make kind of like a little overhand knot while holding the rest of the rope tight. Okay, it'll be tight. It'll come back again, and this rope is like coming apart on me, so bear with me. And you just keep making stacks of overhand knots on it like so, and you could just make as many as you want all the way up. Now, the reason why that's superior is because you notice you can sit there and pull on it all day long, and that knot is not going to come loose. It'll be super tight just like that. Now, a couple of things on ropes. You'll see a lot of different types of aircraft securing techniques out there. One of them is chains, another one is ratchet straps, and the other one is rope. Now, what's the pros and cons? Chains are easy, and that's also their biggest con. Now, you take a chain and you simply will find the length that you want. They'll have like a little eye hook or a little loop, and then you just loop it off on there. Now, chains are good if you don't have any bad weather. It will absolutely hold things, but if you get some really bad weather that's pulling on your wing, there's nothing to give. There's no shock absorbance in there. The chain, the tensile strength is through the roof. So what ends up happening is you end up damaging the aircraft. The wing will eventually pull the grounding point completely out, and it'll give way. So best case scenario is that if you have like a high wind situation, is that there's some sheet metal work that you got to do afterwards. Worst case scenario is there's sheet metal work you got to do afterward at the tie down point, and however else the airplane lands as it flips over. So chains are not ideal, but sometimes that's all you have if you pull into an airport, and as long as there's no weather coming in, it'll hold it all day long and it'll be just fine. The other option is ratchet straps, and that's a popular option that you'll see a lot of people do. That they just find their tie down point, tie it down, and they ratchet strap it super tight. Now, you kind of have the ratchet strap is a good halfway point between the rope and the chain. The ratchet strap will give some because it's made out of nylon after all. But it still kind of has that same sort of dynamic with the chain, is that it may be just a little bit too much. And the guys that regularly work in these really bad environments, they rely on ropes, because the rope, while it's secure and it's not going anywhere, will also stretch and allow the plane to move without damaging the plane. If something's going to break, the rope will break before the plane breaks, and that's what makes ropes the superior one. It just takes a little bit of knowledge and a little bit of time to use them effectively, because not everybody knows how to tie knots. It's easier just to latch on with a chain or a ratchet strap, but not you. You guys are going to be smart and know how to tie the hurricane hitch and know how to tie the bowline knot and a number of other knots that are out there. So yeah, knots.